Hi everyone, thanks for joining us today. It looks like there's still a few people trickling in, so we'll give them a few minutes to arrive and then we'll get started. Hi everyone, welcome to today's webinar, hosted by Matterport and featuring customer HH Angus. Today's webinar is 3D modeling made fast, accurate, and affordable at Toronto Western Hospital. My name is Sarah Suwanjandar from Matterport, and we have a wonderful panel of experts joining us today. First, from HH Angus, we have Melissa Perry and Akira Jones. Melissa is a BIM specialist and Akira is a BIM leader and principal. For those of you not familiar with HH Angus, they are one of Canada's larger private engineering firms, providing services to clients in the institutional, commercial, and industrial sector. Today, we also have my colleague here at Matterport, John Chawalabog. He's our resident AEC expert. Glad to have everyone here today.
Thank you.
Thanks a lot. Great to be here.
Awesome to be here. Looking forward to it.
Great. Let's take a sneak peek at our agenda and some of the items we'll be covering today. Today, we're going to hand the presentation over to Melissa and Akira, who will be sharing a case study of Toronto Western Hospital and how they incorporated Matterport for improved workflow. They will walk you through scanning, uploading, modeling in Autodesk Recap and Revit, as well as equipment identification processes and how they improved cross-team collaboration throughout the Toronto Western Hospital project. Then they'll share an up-close look at the cost and efficiencies gained. And finally, we'll have plenty of time for your questions on the case studies, scanning techniques, the Pro2 Camera, and the Matterport Cloud. They'll also be available to answer questions on modeling techniques used in the Autodesk suite of products. And with that, I'll hand it over to Melissa and Akira to present their case study.
Thank you very much, Sarah. We're both very excited to be here. So to start, we'll cover our learning objectives for the day. We will show you how we gather, organize, and share more information from our sites using the online Matterport Cloud and the Pro2 Camera compared to a traditional site survey. We will also show you how we leverage the online platform to optimize Revit family creation, and we'll discuss how to prepare point cloud models for integration directly into Revit. We will also explore some tips and Revit modeling techniques you can use when you're working with point clouds, and we'll also share some of the benefits and limitations we experienced with the Matterport Pro2. Now, before we dive into our case study, I'll share a little bit about HH Angus. We are one of Canada's larger private engineering firms, and I'm proud to say this year we will be celebrating 100 years of engineering innovation. Over the past century, HH Angus has been providing consulting engineering services to a broad range of clients in institutional, commercial, and industrial sectors, along with a deep portfolio of work in both energy generation and distribution. In 2018, HH Angus won the Schreier Award, which is the top consulting engineering award in Canada. And in 2019, we've been named one of Canada's best managed companies by Deloitte. So it's a fabulous place to work. Now let's dive into reality capture, the process of producing a digital 3D model of a building or as-built site using scanning technology. At HH Angus, we're using photogrammetry and the Matterport Pro2 to document site conditions, share information with other consultants and our clients, and produce 3D models. We'll also explore these features in this case study. and then we'll discuss how we imported the 3D scan data to model existing mechanical, electrical, and piping systems in Revit. One of the benefits you get using the Matterport Pro2 camera is accuracy. Matterport specifies the accuracy of the Pro2 for 3D elements to be within 1% of reality. Granted, this is not as accurate as a laser scanner, but it's still really good, and it provided the needed accuracy for this particular project. You'll also increase your efficiency, and you will reduce your return visits to site. From the comfort of your desk, you'll be able to walk through an entire site and capture measurements. You'll also increase the quality of information that you're getting and provide better site-specific context to the end user and designer. The Pro2 camera has a 4K lens, so you get really, really good quality images. And in terms of productivity, we're able to import a point cloud directly into Revit. Using this reference, our designers can take measurements and identify exactly where to model existing systems. At approximately $3,000, one of the best benefits of the Matterport camera is the cost, and is a much lower capital investment than some of the comparable 3D laser scanners that are on the market. And most importantly, you will save a ton of time in your existing workflows by using the camera. So with that, I'm going to hand it over to Melissa Perry, our BIM specialist and our in-house expert on the Matterport camera.
Thanks, Akira. So here we're going to highlight some of the ways that we use reality capture and the Matterport cloud at HH Angus. So we streamline communication by providing our clients and stakeholders with a platform for communication over distance. So with the click of a button, you can send a hyperlink of your entire site to shareholders. And in the video here, this is what they see. So there's a 3D model of one of our sites. And if we dive right in, this is really easy to navigate. So we can move to the next scan location by clicking on one of those circles on the ground there. So that's where we've gone and moved the scanner and taken a 360 scan. We can zoom out to a floor plan view and dive right into another part of our site, our room there. And next comes the matter tags. So we're actually able to tag our equipment and embed media content like YouTube videos, for example, fully sound and video enabled. And we can embed hyperlinks to manufacturers' websites as well. Now, if we zoom out to a 3D view, we can pivot around and click on another matter tag. That we've tagged a piece of equipment there with, I think, 152-page PDF data sheet embedded, which we can then open up full screen and save and share for later on. So why did HH Angus choose the Matterport Pro2 over another laser scanning option? And it really came down to the cost and the value. We found that the Pro2 suited our needs and our budget better than a more expensive laser scanning option. Our total investment, which includes the Pro2 camera, iPad, hard case, 3 tripods, Matterport cloud subscription, development of our own in-house training, and the time that it took to train 27 of our staff to use it, totaled $13,500 US. So all of that hardware, subscription, and the training is less than the cost of just a laser scanner, which retails around $20,000. Now with the Matterport cloud, we have the added benefit of 3D models available online, OBJ and point cloud files for Autodesk integration, measurements of our space, 2D photos, matter tags, the ability to embed information, and the list goes on. So all of the benefits that come with the Matterport cloud subscription and the many ways we use it far outweigh the cost.
Melissa, this is really good information and really appreciate you guys sharing it. Most of the time we hear from customers about how simple the Matterport camera is to operate or the ease of use because your Matterport cloud account does the processing for you as primary reasons for someone using Matterport. Here you have a great example of the value of the upfront investment in Matterport versus other 3D laser scanning technologies out there, and how Matterport is a great add to the 3D reality capture toolbox industry professionals are utilizing.
Next, I'll showcase our scanning workflow for one of our projects at HH Angus, from scanning our site to processing our point clouds using Autodesk Recap Pro, and finally modeling existing mechanical, electrical, and plumbing systems in Revit. So our project is 17,500 square feet of mechanical and electrical rooms of a central utility plant for Toronto Western Hospital. Our site is that building towards the bottom of your screen there with the really tall stack. Now, the scope of this project is the refurbishment and replacement of mechanical and electrical systems to improve reliability. Now, this includes the central steam, chilled water, and emergency power servicing the facility's operating rooms and general campus. HH Angus's role is prime consultant and mechanical and electrical engineer. Now, the hospital required a record of their existing facility systems. Our reality capture goal for this project was to document areas of interest with enough detail to produce a point cloud, which we could then use as a reference in Revit, paired with the Matterport walkthrough to model all the existing systems. It took 2 of our staff members 30.5 hours to scan all 17,500 square feet of the mechanical and electrical rooms, which brings us to about 575 square feet per hour. Now, this is a lot slower than our average scan time for similar projects, and this is because we needed to spend time on additional scan points in clustered areas of the site to help produce more reliable scan data. Now, clustered areas and congested areas with a lot of piping and ductwork is more surfaces to capture. Since we needed to model all of those systems, we needed to spend the time scanning them, making sure that the scanner had a line of sight to all of those surfaces to capture, whether it be very high in elevation or very low. Now, what the scanner sees is what you get, so a line of sight is very important. If we didn't capture those surfaces, then that data wouldn't exist in our model, and it wouldn't exist in our point cloud when we link that into Revit. And you can't model existing systems in Revit when the reference data isn't there. So if you want to model it accurately, you will need to take a lot more scan positions. A little bit of extra time is definitely worth capturing reliable data. Moving on to our equipment checklist, we have the Matterport Pro2, which combines photogrammetry with structured light to produce its result. It captures the 2D RGB color data and the 3D depth data. The 4K lens ensures we have those high-quality images to review back at the office. We typically get 8 hours of scanning on a full battery charge, and we can perform one scan in less than a minute, from the point we push scan to alignment, and then a review of the data captured in the app on the iPad. And we use the iPad to connect to and to control the scanner. The scanner and iPad connect to each other via Wi-Fi connection. Then we use the Matterport Capture app to set up our job and begin scanning. Once we're done, we upload our scans to the Matterport cloud where they are processed into the final 3D space. And we have 3 tripods. We use our smallest Manfrotto tripod to place on top of equipment to get those really hard to reach areas. The medium-sized tripod captures up to 8 feet in elevation, and the largest of the 3 tripods, a SitePro Survey tripod, captures up to 12 feet in elevation for those double height mechanical rooms. We have a set of portable LED lights. Now, these are really important for capturing darker areas. If the areas are too dark to capture, it results in a blind spot in your point cloud, and the LED lights are a really great solution for this. And lastly, to help improve the visual quality of the space, we use visual alignment markers, or April tags. We tape those to flat vertical surfaces, like walls and equipment, so that the camera can use those markers to help place the scan in the correct location, and then use the depth information to fine-tune that alignment. Plan your scans and then scan your plans. Always plan out your scanning first. Now, generally, we start scanning in a grid pattern, so side to side or back and forth, and later on this helps navigate the 3D model online much more smoothly. Now, sometimes this isn't possible because of site conditions. Those mechanical rooms can get quite clustered, but the most important thing is that each scan must have a line of sight to the previous scan, which is about 8 feet. Now, this way, the scanner can use the depth data as well as the visual alignment tags, or the April tags, from the previous scan to identify the correct location of the next scan. If your scans are too far apart, you'll encounter an alignment issue, which we'll discuss later. And plan when you're going to change your tripods or switch to a higher elevation or lower elevation. And a technique that I find works best is to scan an area at a lower height for maybe 8 scans, and then switch to a taller tripod and scan that same area at a higher elevation. This ensures you've documented the whole area of the space from top to bottom. And then you'll switch back to the smaller tripod and repeat that whole process. Now, by the time you're done, you've captured the entire site top to bottom without issue. And some redundancy in data is a good thing. Capture as many scans as you need. You want to more densely scan specific areas of interest. So some examples include those clustered areas with a lot of piping and ductwork, as well as in front of equipment labels, which you can easily read back at the office because of that 4K camera lens. Really good quality images. So to generate a high quality point cloud, it's really important to capture all sides of a surface. And remember that what the camera sees is what you get, so take more scans with that line of sight. The Pro2 uses a structured light or infrared 3D sensor, so it's important to illuminate dark areas with those portable LED lights. And a good example of this is shown at the bottom right on the slide here, where we used our portable LED lights to scan inside of that exhaust plenum. And with every project comes some lessons learned. So our visuals we have up on the slide here demonstrate the importance of following best practices while scanning. So we ensure employees are properly trained and pair them with someone experienced in using a scanner for their site visit. Now, by following those few easy scanning techniques we talked about on the previous slide, that'll ensure that you capture the most reliable data. And scanning your office or your home will help you familiarize with scanning techniques when you're first getting started. Now, the Capture app on the iPad ensures that you are capturing everything correctly before you leave the site. So you can check a preview of what the scanner has captured before you continue to scan. Now, the images shown up here is what happens when you don't follow best practices. So the image on the left shows what a site on a different project actually looks like in reality. And the middle image is the mesh data of what was captured with the scanner. So notice the duplicate of that open door with the sign on it, and that duplicate is 3 feet 2 inches or over a meter away from where it is in reality. And now our point cloud is generated from that mesh data, so the duplication of data was translated over to our point cloud, and we couldn't use it for the as-built modeling we needed it for. So because of this, we had to go back and scan the entire site. And here's a little comparison of what that looked like. So on the left is the original scan data from the previous slide, and on the right side is the data from when we went back and rescanned our site. So going back to the left side, our original scan data, we can see that they started out pretty good. The scans, 1, 2, 3, up until about 10 were in that grid pattern we talked about, back and forth or side to side, and they did have that 8-foot line of sight. But as they kept scanning through the site, those scan points started to get further and further apart, and 15 feet is the maximum distance. Now you can see scans number 12 and 13 there are 36 feet apart, and then moving over to scans 19 and 20, those are 50 feet apart. That's too far. They lost the visual alignment tags, or the April tag data. As well, they didn't use those in the first place, but on top of that, they lost that 3D depth data without that line of sight. So there were no references to place the scan in the correct location, which resulted in duplicates all over the model and very unreliable scan data. So switching to the visual on the right side, when we went back to rescan our site, this shows the data that you get when you do follow the best practices that we've discussed. So we scanned in our grid pattern, back and forth, side to side. We kept our 8-foot maximum line of sight between scan locations. We used our April tags, and we checked all of our data as we were scanning, so we knew 100% that we captured what we needed to. And then we used the point cloud and the Matterport walkthrough for some as-built Revit modeling. It was great, and it was easy. So I like to use this example in my training sessions of what not to do, and it really helps to illustrate why we have best practices. So check as you go. The Capture app gives you the feedback and shows you that it's placing the scans accurately. Plan your scans, scan your plans, follow best practices. And once you've scanned your site, it's time to upload. And we typically upload our models back at the office where we have an internet connection. Once that model is in the Matterport cloud, it's processed through a set of computer servers to create the final 3D space. Typically, our models take no longer than 8 hours to process, but that can be a bit longer if you have over 200 scans or very complex geometry on your site. After processing, we can view, edit, and share the model and download our point cloud. Now, a point cloud is a set of data points in space. So all the points that you see in the image here make up the surfaces of all of the 3D objects that we scanned, and it creates this 3D digital model of a boiler room. Now, the point cloud file we get is colorized and it's registered, and it's in the XYZ file format. Now, your entire model is in one piece. All of the scan points have been aligned and auto-stitched in the Matterport cloud. And this is one of the best features of the Matterport cloud. You bypass having to manually align your point clouds. And now we process our point clouds using Recap Pro to help improve Revit model performance. If we skip this step, our Revit models tend to be very slow, and our designers won't be able to toggle the visibility of different parts of the point cloud as they work. So once we have our point cloud, we will start a new project in Recap Pro. We will work locally instead of off the network to improve Recap performance. And you also want to make sure that your graphics card driver is up to date and that your hardware can run the program easily. Now, we had some issues with this initially, where I ended up getting a better computer for this task, which is great for me now, but it was a real struggle in the beginning. Now, our goal for this is to organize those points into regions and delete points that we don't need, like garbage bins and objects that could be confused with equipment, and then save out those regions to separate files. Now, typical regions we would have for Toronto Western are walls, floors, equipment, ceiling, very basic regions. So here we have that 3D point cloud of our boiler room in Recap Pro. And there's a couple ways that we can manipulate our point cloud here. We can use the limit box to section off different areas that we're going to place, different areas of points that we're going to place into regions. So we've used the limit box here to isolate the points representing the floor, so that will be one region. And then we can use a series of different selection tools to select our points. Now we have the plane selection tool, so you set a specific depth and then select points along that depth. When you increase the depth, you select more points along that plane. We have the fence selection tool, which is a little bit more versatile. It lets you select some oddly shaped objects. And then we have the good old window selection tool. So once you've selected your points, you can create a new region or place those points into an existing region. So the next thing is to remove points from our point cloud that could be confused as equipment or points that we don't need. And I'm talking about things like that blue recycling bin that you see there, or garbage bins, or anything that can be removed from the space that we don't need in our Revit model. So there is a technique to selecting points, because if we just select our points right now, we're going to select points from our floor region and from our recycling bin. And we don't want to delete points from our floor region. So we can either lock that region or turn off the points so that we won't be able to see them to select them. So now we have our recycling bin points selected and we can remove them from our model. So using those techniques is a really easy way to clean up your point cloud. Once we're satisfied with the regions we created in Recap Pro, we save each one out as its own 3D model as a separate file. When we link those into Revit, origin to origin positioning, they fit perfectly together just like puzzle pieces. But before we link in those models, we create a work set for point clouds. Now in our Revit models, this work set is visible in all views so the team can cut section views and see the point clouds right away. But for print views, we turn off the visibility of the point clouds work set. and phasing applies to point clouds. So we link these into the existing phase because they are for an existing facility. So to give an example, we have an equipment region point cloud linked into our Revit model, and we're going to pick another region. So this other region has everything that's not floors, equipments, and walls, and we link that in with origin to origin positioning. Now that's the most important part here, and that makes sure that each individual point cloud region file is superimposed exactly the way that it was before we split out this file. So that when it's all linked together, as you see here, fits perfectly. We select all of our point clouds, we pin those in place so that they will never move, and then we're going to group them together. And with that grouping, we usually name our groups, point cloud underscore whatever the room name is. So with that grouping, it allows us to select our point clouds as an individual single element, which we then manually align in place. And just a note about manually aligning our point clouds. Now we had existing AutoCAD drawings for the hospital. We had a site model and the architect's model containing some levels, grids, and preliminary column locations. Then we used all these resources to align our point clouds. Now there were some discrepancies between the point clouds, the Revit models, and reality, so we required site verification to validate that the clouds were in the correct location. So you can reduce your number of return visits to site, but you can't eliminate them. Moving along to modeling our existing mechanical, electrical, and plumbing systems in Revit. So this image you see up on the screen here is an Autodesk Forge visualization of that boiler room you saw on Clarity. So we're going to cover some best practices for Revit modeling, for modeling your systems, and we're also going to discuss our process for family creation for this project. So working with point clouds in Revit is a little bit different than your typical workflow. It's fun. So let's say we have a run of pipe that we need to model. For example, we would need to know the diameter of the pipe and its location and where it's running to and where it's coming from. So the trick to this is slicing our point cloud and examining it in different ways. And one of the ways we do this is by modifying the extent of the view range. We also use section views with a very shallow view depth. And this allows us to see the outline of all of the points that we're cutting through and measure outside diameters, length, width, and height, as well as measuring the elevation of our points above that reference level. So keep in mind, with piping specifically and ductwork, you only receive the outside diameter or the outside dimensions. So if the pipe is insulated, you won't be able to determine the actual diameter from the point cloud alone. You'll have to use another resource for that. So you can switch the visibility of those region-specific point cloud models on or off to display unique parts of the model, depending on what the designer is working on. And the last thing is our references. So use all of the references available to you. And this includes your 3D scans on the Matterport cloud, existing drawings you might have, floor plans, schematics, the point cloud, and your 3D views in Revit. So to give you a visual of the tips that I was just talking about on the previous slide, we have a floor plan here with 3 groups of point cloud files. Now, we can adjust the view range like we discussed before. So if we raise that bottom extent and the view depth, that will hide some of the floor points there. So we can slice our point cloud at different elevations depending on our view range. We can use section views to slice through our point cloud. Now, this section view has a very deep view depth. So it's a very far section, so to speak. And when we open that up, we can see that there are a lot of points here. Now that's not really useful for me as a designer trying to model something because I don't know what points I'm cutting through and I don't really know what's going on in the space. So I can go back over to my plan view and I can adjust that bar clipping and I can make my section view thinner and thinner until I can see a really good outline of just the points that I'm cutting through. And I can nudge my section throughout my model and see other parts of the point cloud. So back over to our section view, and we'll take this pipe for example here. So I'm going to use a detail line to represent my elevation, because unfortunately our dimension tool doesn't snap to a point cloud, but I can snap to my detail line and then my reference level, and I see that I have 4,700 millimeters or 15 feet in elevation above the reference level. I can use my measure tool to get that 14-inch diameter measurement or 350 millimeters for my pipe. So I've found the location of my pipe, I know its size, but other things that I would do in addition to this is to have my plan view open in Revit with a modified view range to see where that piping is running at the 15-foot elevation. So I would also have a 3D view open to get a sense of the space. And one better is to have the Matterport Cloud walkthrough open on my second monitor, so I know exactly what I'm looking at and I totally understand the systems that are in the space. I can read equipment labels in the Matterport Cloud and identify what systems are running through the pipes, just as long as they're labeled. So using these techniques makes it a lot easier to model existing systems in the correct location. The workflow for family creation for this project was a bit unique. At HH Angus, we have a company intranet where employees can submit a ticket to request a specialist to produce a Revit family. When employees submit those Revit family requests, they include information such as data sheets or equipment sizes or AutoCAD files and such. Then the BIM team will receive an email and will fulfill that request and usually reply with an email touching base saying, this family has been created for you, it's loaded into the project, and then we can all go home. No, I'm just kidding. So the challenge with this project was the volume of families that we needed to create in a very short amount of time with limited information, making our intranet method very inefficient because we would have lots of emails that were floating around and those emails wouldn't contain any information that we could use for family creation. Now this project required more collaboration, data, and insights than our average family request process. So when engaging with the team, I typically request the following information. So what is the equipment identification, the size, any connections that we need, and so on and so forth. So the first thing I need is identify the equipment. So I would go online, look at our Matterport 3D module of our site walkthrough. I could read equipment labels easily or plaques, like you see the North Condensate Tank plaque up here. And if I'm ever uncertain about something, I have an entire building full of engineers who are more than willing to answer my questions. So next are the equipment sizes. I can take measurements from the 3D model using the Matterport Cloud workshop to obtain equipment dimensions. And I can also measure from the point cloud directly in the Revit model just to confirm that dimension. But the most important thing that we need is an efficient way to communicate with our team. So we use Matter tags to annotate the equipment in one central shared up-to-date location. When a Revit family is ready, I would load it into the Revit model and then go online in the Matterport Cloud and tag that equipment with a Matter tag. And inside that Matter tag, it would display the Revit family name and the family type that matched that piece of equipment. So by documenting this data within the Matterport 3D model, our designers can review all the newest tags for equipment available in the model and have it in a list format in Matterport. So this method, combined with consultations with our designers to fill any knowledge gaps, helped accelerate documentation and the Revit family creation process. It was easy and efficient. So we scanned our site, processed our point clouds, and modeled the existing mechanical, electrical, and plumbing systems in Revit. And the hospital was pleased with what we delivered, and this project is still ongoing, and the scope is still under budget, so that's a really big bonus. So scanning took 30.5 hours, so that first image you see on the left side, 30 hours, and the rest of our workflow, so all of the point clouds that we processed in recap, plus all of the modeling that we did, was 300 hours. Now those first scanning hours are the most important. We need to make sure that we capture good, reliable scan data to make the rest of those 300 hours a lot easier. The Matterport Pro2 camera uses structured light to capture 3D data designed for indoors as-built conditions. So our challenge was infrared light from the sun, which presents alignment issues. Now, our solution for this, or our workaround, was to capture a 3D scan and then use the 360-degree panoramic snapshots and then place them on the site map using the Capture app on the iPad. So here's an example of that. So we took one 3D scan, and if we zoom out to our 3D model there, you can see all of our panoramic snapshots with that little sliver of 3D geometry. So you can click on a snapshot, dive right into the model, and as long as you're still taking your snapshots in that grid pattern, back and forth, side to side, when you go to see a list of all your snapshots, if you click on the next one you took, you just take one step forward in the model. So that helps you navigate through your space, even though you don't quite have that 3D geometry. And you can also take just regular 2D snapshots from your panoramic images, and this is real time. You just hit your snapshot, your photo is saved, and you can view and edit and download all of your photos for later. So although you won't receive a 3D model, you are capturing 2D data, which is very helpful to have those images online, organized, and in the context of one central site location. You can also try to scan in low light conditions or overcast skies or at dusk if you really want to scan outdoors. So that being said, we probably shouldn't have scanned a rooftop on the nicest day in July with all of that bright sunlight, but it was a really great site visit, and I think we had the best view of the city. So I'll hand it over to John now for some outdoor scanning options.
Thanks, Melissa. You bring up a great point about the Matterport Pro2 camera and the impact that bright, direct sunlight has on its ability to provide 3D data. And the solution you used is a very good one, and one that we see a lot of customers using. We also wanted to point out a couple of other options as well. For those outdoor environments that need 3D data, a great solution is to use the Leica BLK 360 LiDAR scanner with the Matterport Capture app. LiDAR is not impacted by direct sunlight like structured light is, so we're able to keep the 3D and the images intact and offer the same Matterport experience even in those challenging outdoor environments like the one you had here. In addition to using the BLK, we now have the ability to support the conversion of 2D images to 3D with the launch of Cortex earlier this year. With Cortex, we can take 2D images from the Pro2, a Ricoh Theta V camera, or the Insta1 360X camera and convert those to 3D. When using this feature, you don't get the point cloud or other 3D elements like you would with the Pro2 or a LiDAR scanner, as the accuracy just is not good enough yet. But because of the Cortex processing engine, we allow a user to have a seamless experience of walking through the space in 3D in the Matterport showcase, just like it was captured fully with the Pro2 camera.
Okay, thanks, guys. That was really, really interesting. Now, before we end here, I'm going to walk us through a quick cost analysis that we've done based on some of the information we've gathered on previous projects. On the left, we have the Toronto Western Hospital staff, and on the right, we have two other projects with a similar scope of survey work where we completed traditional site surveys. So the first example was for a survey that we completed at a 24/7 psychiatric facility outside of Toronto, and this was for a mechanical and electrical infrastructure upgrade. So the area in question was about 30,000 square feet, and this took about 55 hours on site to survey, and we collected about 1,000 photographs on site. And so if we take into account all the time that it took, this cost about $5,300 US dollars. Now, if we look at using the scanner and our average scan time, which is about 1,200 square feet an hour, this would have taken about 27.5 hours. We would have gotten all that extra information from the 3D model, the cloud service, and the point clouds, as well as the ability to measure, and at a cost of about $2,700 US, as opposed to the $5,300. So you can see a significant cost savings there.
So I want to thank Melissa and Akira for sharing the case study about the Toronto Western Hospital and HH Angus's experience with the Matterport system and taking data into Revit. We've got a lot of questions. We'll try to get through as many as we can over the next few minutes. So if you have some questions, please submit them in the question section on the GoToWebinar control panel. To start, Melissa, question for you. Imagine you had some expectations going into the project with the Matterport technology. Was there anything that surprised you once you started to use it and using Matterport on this project? Surprised you in terms of about the technology and its capabilities?
Hi, John. Yeah, thanks. That's a great question. So I was impressed at how easy to use this technology was. And as I mentioned in the webinar, I developed our own in-house training programs for teaching our staff how to use this technology and best practices. And it was using this technology, it was very simple to, create and formulate all of those training materials, and there was overwhelming support from online, from the Matterport forums and your tech support for any help that I needed. So it was the ease of use that I was really impressed with.
Awesome. Along those lines, I got a question here I'll answer about registration. Someone was wondering if we were going to cover registration. And kind of along what you said about the simplicity, the nice thing with Matterport is once you've captured in the field, you upload your from the Capture app. So when you have a Wi-Fi connection, and Matterport will process all of your scans together into a single model for you. Typically, that's within 24 hours. A lot of times, it's a shorter amount of time. It kind of depends on the size of the project. But we do all the processing for you. And push that back to you. So there's really no registration process that you have to know or go through. Next question, Akira, this one's for you. And it kind of refers to how your customers are reacting to you using Matterport. And I guess maybe two aspects to it. One is their use or your use of the Matterport Dollhouse with your customers. And then the second piece of it relates to the fact that Matterport's a cloud-based solution, and sometimes we hear questions about data security and things of that nature, and how are your customers reacting to you using a cloud-based solution?
Thanks, John. Yeah, I mean, both are great questions. So in terms of how our clients have reacted, I mean, overwhelmingly, it's been very positive. The end users or the clients that we work with, once we share the scans with them or say that we're going to be doing scanning, they're very interested to see, what we're doing. But then the end result they feel is a very great or useful communication tool. Specifically when we work on projects with other consultant partners, it becomes very easy to look at the space and share information about the space without having to be in the same room. So we often share the information with the architects that we work with, other consultants, as well as the end users. And everybody has found that it's been a great tool for communication and planning as well. Now, in terms of the security issue, I think that for the most part, most of our clients don't seem to have a big concern, but we don't, a lot of the work that we do is with public institutions and commercial spaces where they're not really concerned about security. I will say that, due to some of the work that we do with some of our technology clients or data center clients, there are inherent things written into our contracts that we can't actually host data on third-party servers. So that has been a bit of an issue. And we've also had questions about whether we can basically redact or blur information in some of the scans from some of our other clients who are trying to maintain some confidentiality. So that is one thing an issue that we've run into.
Yeah, we get the blurring of things often. Couple more points on that. So, Matterport uses AWS servers and has the security protocols in place that they have, and we can share that information with anyone that is interested. Just send us an email and we can share that information. The other bit as well is you do have the ability to keep your models private. So someone would need a login and a password to access the data and information with your models versus having public models. So that's another way that some customers are dealing with kind of the cloud-based security questions. Melissa, another question for you, and in and around, I guess, the April tags, a couple of questions. One is, where did you get the April tags? And two, can you talk a little bit more about their helping in the, you know, minimizing the distortion or skewing of walls in the scanning process?
Yeah, so I was able to download 100 April tags from the Matterport website totally for free, and laminated them so we could reuse them easily in each space that we scanned. So in terms of reducing distortion, I have noticed that using the April tag, definitely reduced distortion. So we put them up on flat vertical surfaces like walls or equipment, maybe a maximum 15 feet apart, usually around eye level, and that will definitely reduce the noise that you see on the perimeter of your model. And scanning in that grid pattern also helps a little bit for that too.
Awesome. I guess kind of on that note, best practices, a question I'll answer is max distance between camera locations with the Pro 2. So the Pro 2 has a range of 1 to 5 meters. That's the structured light range that it can pick up the three-dimensional data. Obviously, when scanning, you want to have overlap. And so you want to not push the limits of the camera itself when going between camera positions. On average, you know, we see that to be kind of in that 2 to 4 meter range between camera setups. But again, it depends on your environment and what's in the environment. Another question for you, Melissa. The scanning heights, was it mandatory for you to scan at 2 different heights in the space, or why did you scan at different heights?
Yeah, so scanning at different elevations, it really depends on your needs and what you're using that Matterport space for. For Toronto Western Hospital, we needed reliable point cloud information that we could use as a reference in Revit to model those systems. So it was definitely required for us to scan at different elevations in order to capture all of those surfaces. Because when you're in a double height mechanical space, you have to scan up to that 12-foot area, or else you're not going to capture the surfaces of the systems that are running through at that elevation, which results in a blind spot in your point cloud and then nothing to model from in Revit. So to capture that good, reliable data that we could use, yes, I definitely recommend scanning at multiple elevations.
Awesome. Akira, a question for you from a customer about the cost analysis. The question here is, were the traditional cost analysis numbers based on creating Revit models from photographs and manual measurements, or just capturing photos and cataloging them? So maybe expand a little bit on the comparison between Matterport and the traditional method you outlined.
Certainly. I mean, the projects that we did, the traditional site surveys, were not capturing information for Revit projects, but it was a direct comparison with the Toronto Western because the 30.5 hours was strictly for the survey work. So I was just comparing, similar scopes of in terms of the survey work itself. And I would argue that even though the other two projects weren't for a Revit project, we still would have been able to gather significantly more useful information by using the Matterport scanner, and would have saved time in the process. So hopefully that answers the question. Appreciate that. I have a question here, and maybe I'll start with an answer, and then Melissa, if you want to add anything to it, the effect of moving objects on scanning. So Matterport, with the Pro 2 being an image-based and structured light camera, moving objects can have a big impact. Obviously, it would create blur in your images, and so that could create some distortion if you have people or objects moving through the space. Also, for cloud-to-cloud, for point cloud generation and the registration of point locations in the field,
moving objects can affect alignment. And so you want to have as few, foreign objects in the space as possible, and try to clear out any people in the space that don't need to be there as necessary. Melissa, I don't know if you want to add anything or what you actually saw in the field with using it in a working environment.
Yeah, exactly. So we've had some issues with, people being in scans, typically ourselves scanning. It happens in training quite a bit because, people want to watch the scanner as it scans, to know how it works. But typically, because we as people are foreign objects in our scans, so typically we'll set up the scanner and, go hide behind a chiller or whatever we can find, and then do the scan so that we are physically not present in that scan location. And that really helps with alignment of the scans as well.
John, just to add to that though, we did recently do a Matterport scan of a hotel lobby, which was a large double height space, obviously a lot of foot traffic, and we were able to capture a reasonably good scan from that. So, it isn't ideal, but we found that it can still be worked around.
Awesome, thanks. All right, next question, Melissa. You said you saved recap independent regions. Can they be saved as separate files in recap?
Yeah, so what my process for that is I'll start with the model that contains all of the different regions, and then I'll save as, and then rename that file to the particular region that I'm keeping, like equipment, for example. And then in that file, I will delete all of the points and regions except for the equipment, and then just hit save. And then I've got that one single region file, and I'll just repeat the process for however many regions I have.
Excellent, excellent. Okay, another question, maybe Melissa or Akira. It has to do with the example you showed of removing the trash can. It leaves a hole in the point cloud. What do you do to repair that hole or fill that in when taking that over into Revit?
Well, that's an interesting question. I think that there is no way to repair the point cloud per se, because those points are gone, but we are still able to model the floor accurately with the available information, assuming that the slab is reasonably level over that small area. So we find that it wasn't really an issue in terms of modeling the existing structure, and the few areas that we had to remove, like a facility operator's work cart or something like a recycle bin.
Excellent, excellent. Appreciate that. All right, we're going through the questions here, winding down a couple more before we wrapped up. Melissa, another question about the regions. Can you shift regions to, the question is, we have seen some larger areas between levels that is exposed when modeling a pipe that passes from lower levels to upper levels. Is this to be expected as slight errors compound? Can you shift regions to account for this, or is there a better way or best practices for scanning on site to eliminate these types of errors from room to room or level to level? Does that, you understand?
Yeah. Yeah, so I mean, you're never going to be 100% accurate all the time, so there is understandably going to be that margin of error. In terms of shifting the regions for the point to accommodate for that, I mean, one thing that you could do is when you're manually aligning your point clouds, you could manually align those regions for pipes if that's how you have separated your points, so that it kind of flows through the spaces from room to room a little bit better.
I would say for Toronto Western as well, we use larger architectural and structural features to align the different regions. So one of the main reference points was the large stack. It provided us a good curved surface that we could align a lot of the point cloud regions to. So that's how we approached it on Toronto Western. But as Melissa said, there are other ways that you could look at aligning your point clouds together.
Excellent. Okay, last question here for both of you. And I guess, you know, going into this project and others, and you've been using Matterport for a little while now, are you using it in areas that you didn't expect to use for your business? Any new use cases or project types? Obviously, you know, there was some intent behind, you know, investigating and adopting Matterport for, you know, a specific project or use case, but has your use of the technology expanded beyond that initial scope when you first started to look at the technology?
Certainly, John. I mean, when we first got the scanner, it was really as a survey tool. And in fact, the scan to BIM workflow was something that came after the fact when we realized that we could get the point cloud information. But I would say that the most interesting kind of outcome that we have found is that we've started to include the scan links in our contract documents when we tender things out to the contractors, because it provides a useful communication tool and reference for the contractors after they come through the site walks. And we've also been able to use the scan information to develop demolition scope for projects. So instead of, you know, spending the time to model a lot of existing infrastructure in Revit that's simply going to get demolished, we define the demolition scope in the scan and provide that to the contractor like that. So it has, those are a couple of the ways that we found that, some innovative ways that we've been able to use the scan information.
Excellent, excellent. Well, again, thank you, Melissa and Akira, for your time today and sharing the project there at Toronto Western Hospital. I'm going to turn it over to Sarah now, who's got a couple of notes about where and how you can view the webinar later. Sarah, all you.
Thanks, John, and thank you to Melissa and Akira for sharing all of your insights and your experience today. For all the attendees still on the line, be on the lookout. I'll be sending out a recording of today's webinar so you can review it again at your leisure, and you can also share it with colleagues. And also be on the lookout for Melissa's 3-part blog series that will be hosted on Matterport, where she reviews all of the information kind of play-by-play that we shared in the webinar.